We start to learn the polynomials, synthetic divisions, okay, last week. And today we are going to have more hard questions. First, let's see here. This is a polynomial. And they already give you the synthetic table, okay? They already give you the synthetic table. The synthetic table, we can show this one as examples, okay? Let's see here. The way we do the synthetic division is this. When you see these polynomials, you order them from higher to lower, yeah? If it's organized like this, you're lucky. If it's not, you first start them from higher order to lower order. Okay, and this is 32 is a constant term, which means x to the power 0. So you put on the last position and you start to copy down all the coefficients. You write down as 1, 1, negative 18, negative 16, and then 32. If you want to try, you know the PRR, okay? Possible rational roots. Possible rational roots is using the factor of this constant term divided by the factor of this, okay? So what does that mean? So you could have roots of positive or negative factors of 32, which is 32 factor could be 1, 2, 4, 8, 16, and 32. Factor of x to the power 4 coefficient is 1, okay? Yeah, 1 has just 1 by 1. There's no other integer factors. And you can give a try for positive 1 first. So for this one, you copy down. You copy down as 1. And then you do 1 times 1, which is 1. So you put here. And then 1 plus 1 is 2. And then 1 times 2 is 2. So you put 2 here. Negative 18 plus 2 is negative 16. And then negative 16 times 1 is negative 16. Next, negative 16 minus 16 is negative 32. 1 times negative 32 is negative 32. 32 minus 32 is 0. Okay? That makes sense? Okay? So when you see here 0, that means this one is a real roots. Okay? This one is a real roots. This synthetic table gives you the result already. They already put the answers over here. All right, okay, so they already give you the synthetic result. You don't need to do this by yourself again. I just show you how this come from, which is showing as this layer, as this row. Now, when they ask you, what are the roots of the polynomials and how can you tell? Aiden. Aiden.
Yeah.
Okay. So based on this, how do you tell who are the roots for these polynomials?
Sorry, ask again.
Who are the possible roots based on this table?
For which polynomial? Oh,
yeah, for this.
X. You wait for x power 4 plus x cubed minus 18x squared. That
yes.
one? Okay. 4, 1, negative 2, and negative 4.
So the roots are 4, 1, negative 2, negative 4, because this ending number is 0, correct?
Yeah, right.
Okay, so that's their roots. Okay,
Okay.
So you can do your own synthetic division, try put 4 here, yeah, and you can verify. And how can you tell? It is because the last number is 0. That means those are the roots, okay? Next one. You ask P3 and P negative 1. P3, you can plug in 3, okay? You can plug in 3. So do a quickly mental math. Let's do here. P3. This is what? 3 to the power 4
81
plus 3 to the
27.
power 3, and then minus 18 times 9, and then minus 16 times 3, and then plus 32. Okay, you can do the calculation and tell me what's this answer.
81 plus 27 minus 26. All right,
How much?
hold on. 81.
Other
plus
people can text me, okay? If you know this
minus
equals what? How much is this?
It's negative 70.
That's correct, which is this guy, okay? If you plug in 3 into here, this guy will be exactly the same last number as you show over here when you do the synthetic division, okay? Yeah, it is always true. So if they ask you, P3 is how much? P3 is this guy. If they ask you P negative 1 is how much? P negative 1 is this one, okay? Yeah, you can plug in. It's always equals to the last digits when you do the synthetic division, okay? It is always same answers as what you see in this table. Next one. Aiden. Aiden. Yeah, I still call you because most students haven't learned this in their school yet, right? Yeah, you already learned this, correct?
Part of it.
Okay, yeah. When you see this guy over here, what's this polynomial? What's the polynomial based on this?
Negative 2x cubed minus 11x squared minus 12x plus 9.
Okay, 9 corresponding to the constant term.
Right.
This is x term. This is x squared term. And this is x cubed term. So that's this times this, this times this, this times this, and then plus this. Okay.
Okay.
Yeah. Let me ask you this. If you don't have an x term, what do you put over here?
0x.
Yes, you have to put a 0 here. Yeah. If you don't put a 0, your synthetic division will be wrong. Okay. Okay. Now, they may also ask you the y-intercept. What does y-intercept mean?
What point does the graph intersect with the y-axis?
So your x will be
0.
okay.
And it'll be a point.
So that's corresponding to this, right? So that just means when x is 0, y is 9. So that's your y-intercept. Okay.
Right. Yeah.
Okay. What's the possible rational roots?
It could be 1. It could be plus or minus everything. So it could be either positive or negative, and then it could be either like 1, 3, 9, 1/2, 3/2, or 9/2.
Very good. So you have those combinations. Your numerator is factor of 9. 9 could be 1 by 9. 9 could be 3 by 3. So you leave this on the top. And then you leave the 2 factor on the bottom. So could it be 1, could it be 2. So you might have 1 over 1, 3 over 1, 9 over 1, or 1 over 2, 3 over 2, 9 over 2. Correct?
Correct.
Okay, so that's all your possible rational roots. Now, based on this table, who is one of the roots?
-3.
You are looking for, when you are looking for the roots, you are looking for the last term to be 0, okay? And this guy to be 0, so -3 is one of the roots.
Yep.
Now, based on this table, okay? Based on this table, you find one roots over here, yeah? This is one of the roots. X is -3 is one of the roots. X plus 3 is the factor of this polynomial. And you might wonder, is this really correct? Yeah, we can check by long division, right? We can check this by long division. So let's give a try. So this is -2x cubed and then minus 11x squared, then minus 12x, then plus 9, correct?
Right.
And then we can divide it by x plus 3, okay?
Mhm.
-3 is one of the roots. X plus 3 is one of the factor. Yeah, go ahead, tell me what I can do.
What do you mean? You mean like the next
The long
question?
division.
Oh, the long division. Oh, okay. So first at the top, you write -2x squared.
So you have -2x squared.
Yeah, and then at the bottom you write -2x cubed minus 6x squared at like the bottom.
So I write down this.
Right, minus 6x.
And then minus 6x squared.
And then you subtract it, so that cancels out the -2x cubed. And then, yeah, that becomes -5x squared. Bring down the -12x. At the top, you write -5x. And then at the bottom, you write -5x squared minus 15x. Subtract, so the -5x squared cancels out, and then you're left with 3x plus 9.
Mm-hmm.
And then you put plus 3 at the top, and that's 3x plus 9. Yeah.
That this is perfect. Okay, so
Yeah.
after you do this long division, you find out this is divisible. Okay, this guy is divisible by this one because the remainder is 0, and this is a quotient. Look at this. When you have -3, if you do the synthetic division, you have -2, -5, 3. This guy is exactly corresponding to here, right?
Right.
Yes, and -2x squared minus 5x plus 3. 0 is the remainder. If you have a remainder of 0, this guy is divisible by this, which is saying that guy is a factor of this. Correct?
Yes.
Okay. And there's another thing. Now, so you watch out this table. Even though we found one of the roots, which is here, based on those things, okay, if you have, so for example, if you have a function, you have 1 point negative, 1 point positive. Between them, there must be a roots because this has to pass, yeah? This function has to be connected. So based on this hint, there are other roots in this table. Don't see the answer. Everybody look at this based on the information. Can somebody text me? Everybody, if you know the answer, text me. In what location there are other roots? One student text me the answer. Is there any other suggestions? So what I'm saying is, you know, when we draw those polynomials, okay, yeah. Negative 2x cubed minus 11x squared minus 12x plus 9. This is a polynomials, yeah. This is something like that, okay. And this is a continuous function. And right now, all the function we learned so far, like linear function, quadratic function, or polynomial functions, they are all continuous. If it's a continuous function, if you have 1 point, for example, fx1 less than 0, if you have fx1 less than 0, fx2 bigger than 0, there must be another value, which is x3, fx3 equals to 0. x3 is between x1 and x2, okay? Yeah, if you have 1 point below the x-axis, 1 point above the axis, there must be a point which touch the x-axis, and this point is between these two values. So based on this information, look for this table, who might be one of the roots. And you notice that this is negative, this is negative, this is negative, negative. But from here to here, this is negative, this is positive. What does this mean? So if I roughly, even though I don't know the graph shape yet, but I'm able to draw a point. I say F1 is at negative 16. So my F1 is on here. F0 is at 9. Okay? So my graph passes these 2 points. If my graph passes these 2 points, there must be a point where it crosses with the x-axis. Does this point has to be exactly 1/2? Not really. I can make it look like this, right? Yes. Correct, Aiden?
Correct.
So this point does not have to be 1/2. Maybe it is 1/2, maybe not. You don't know. You can only say between 0 and 1. Okay? There is a roots which pass through the x-axis. Does that make sense?
Yes.
Because F0 is bigger than 0. F1 is less than 0. And 0 less than x less than 1. There must be a value of x so that fx equals to 0. Okay?
Okay.
And next question. Could the root between 0 and 1 be rational? Between 0 and 1, there are infinite many solutions. Yeah? 0.001 satisfy between 1 and 0 and 1. 0.5 also satisfy between 0 and 1.
It's not,
Yes. And
0.
yeah, and you know, between 0 and 1, there are so many infinite numbers because you can have fractions, which is rational number. You can have irrational numbers. For example, square root 2 over 2. Square root 2 over 2 is what? Square root 2 is about 1.414. Divided by 2 is about 0.707. Yeah, this guy also satisfied between 0 and 1. So this could also be one of the roots. And the question here is asking you, could the roots between 0 and 1 be rational? If they ask you, you already confirmed from here to here there is a roots. Now you need to check if this roots is a rational or a irrational. So this is the time to check your PRR. Okay, this is the time to check your PRR. Yeah, I know that this part is definitely too hard for most of the students in this class. If you haven't learned Algebra 2 yet, even for students who are learning Algebra 2 pre-P, this is also hard, okay? But high school math is supposed to be hard. You need to get ready for college. That's why it has to be hard. So they ask you, is this root rational? Then you can confirm from this table. If you have such kind of roots, then you say yes. And not always, okay? Sometimes you find something like from there to there, but you don't have this kind of fraction in this table, then you say no, because there's no such values in the PRR, okay? We will see the example of no in the next few questions. Next one, find all the 3 roots. As I mentioned before, highest order is 3. Total number of roots are 3, okay? Total number of roots means real roots plus imaginary roots, okay? You don't know what roots you have yet, but you know the total number of roots is the highest number of this, okay? Now, we already use the long division. We know that this guy divided by this guy is here. We already know that. Or we can tell from this synthetic division table. Yes? So you want to look for the other 2 roots, then you need to solve this one. Correct, Aiden?
Correct.
Yes. And go ahead quickly solve this one. Yeah. Go ahead quickly solve this one. Everybody type in your answers for the roots of this one. You can do factoring. It's not hard.
Is -3 a double root?
-3
Yeah. Is it a double
is
root?
a double roots. That's right. So when you count the total number of roots, when you count the number of roots, you need to say, you might say, hey teacher, when I see this graph, you only have 1 root, 2 roots, but you told me the total number of roots is 3. Why? It is because this guy is a double roots, okay? This is a duplicate roots. You need to count it 2 times. You count as 1 time, 2 times, 3 times. So you have 3 roots. Make sense? Okay. Now, so when you do the factoring, you figure out one of the roots is here, one of the roots is here, and you already have here. So that means you have a duplicate roots at here. So when you draw this, yeah, when you draw this, when you sketch the polynomials, you put the roots from left to right, -3, -1, -2, -3, and then 1/2. This is 1, here is 1/2. So you get the roots here and the roots here. And you have a y-intercept. You have y-intercept of y equals to 9. So you put a y-intercept over there. And then you have those leading term. Coefficients is negative. Yeah, and we learned this last week. This is odd. This is odd. So it's going to go up like that, or going down like that. If the leading term coefficient is positive, you do this way. If the leading term coefficient is negative, you go this way. So the polynomials should come from this position and going down. When they met this is an even number roots. So it is bounced. And then it's going to cross this y-intercept. This gap will not continue going up because there is a roots pulling down. Okay, that's how this graph looks like. That makes sense, Eden?
Yes.
So this is a bounce point, okay? This is a bounce point. And then this guy will be pulling down. Okay, that's what this graph look like. I would also like to introduce the end behavior, okay? This is end behavior. That means when your x is negative infinity, so when your x approach to negative infinity, which is your x go all the way, okay, to the left. When x go to negative infinity, your y will approach to positive infinity, okay? When your x approach to positive infinity, your y will go to negative infinity. That makes sense? Yeah, this is when you analyze your y value, when your x approach to negative infinity or positive infinity, this is called end behavior. Let me ask students, is the thing I teach here too hard? Text me the messages. How about other students? Yeah, I know that Aiden and Ryan can understand. Other people, give me some feedback. If you don't give me feedback, I will just keep going. If you give me feedback, I might adjust the speed a little bit. But you have to let me know. Yeah, this topic is definitely hard to understand, okay? Because the pandemic, all the school is teaching online, and also because of winter storm, and school don't have class, school closed for 7 days. So all right, yeah, I see Olivia, Aiden, Ryan, Brandon, Lucas. Yeah, other people give me some feedback. Otherwise, you will keep feel confused and not understand, not being able to understand. All right, I see some people ask to go a little bit slower. Okay, yeah, I'm going to teach in details for number 3. Number 3, They ask the synthetic division table. The synthetic division table is showing over here. And they ask you, what's the polynomial being divided? I can really tell you, for students who do face-to-face the last several years, when they take the quiz or test for the polynomial part, the synthetic divisions, the roots, okay, and drawing the polynomials and answer those questions. Many students grade really horrible. This is the place you can see very bad grade. So I want to help you to pass this part, okay? The first question is not hard. Ted. Number 3, okay? Question 3, number 8.
Yeah.
You start from this last and you call this a constant term, okay?
Okay.
Yeah, so this is constant term. You can write down this, no problem, right?
Yep.
So what's this polynomial? What's this polynomial?
X3 from negative 4x.
X cubed. Can you say X
Or
cubed?
yeah, x cubed. Yeah, x cubed. Negative 4x cubed.
Minus
not,
4, minus 4x
yeah,
squared.
Minus 4x squared.
And
And negative 2x. Wait.
minus 2x.
Minus 2x.
And then
Plus 12.
that's it. Okay, that's it. That's the answer. Next, they ask you, where is your roots?
Two, I think.
When they ask you the roots, you look for your synthetic table to see where it give you a 0, okay? All right, so 2 is your roots. How do you check your y-intercept? How do you check your y-intercept? Look at this. Is this the polynomial you told me just now?
Yeah.
Y-intercept is you plug in x to be 0. 0,
Oh, okay. Yeah.
0, 0. So 0, 12 is your y-intercept, right?
Okay.
Yeah. Please, if you write down 12, teacher will give you no point because 12 doesn't mean anything. It's y-intercept is a point. So you have to give me this format, 0, 12, okay? Right?
Yep.
And you can also get the answer immediately from here. Yes? Correct?
Okay.
Okay, this is your y-intercept. And then they ask you P negative 1. P negative 1. P negative 1 is what? P negative 1 is this guy. If you don't believe so, you are welcome to plug in. What you do is you plug in, okay? P negative 1. When x equals to negative 1. Ted, go ahead, do this calculation and tell me your answer. What's the answer?
Um, 17, I think.
How much?
Wait.
This is -1. Negative
Yeah.
1 squared is +1. This is +2. Here is +12. How much?
Oh wait, that's 9.
Yeah, that's 9. Yeah, you can plug in, but you notice that this is exactly the answer over here, okay?
Okay.
Yes, that's exactly this answer over here. And then P -5. Yeah. Based on what I teach you, P -5 is who?
-203.
That's just the last number, okay? They already did the synthetic division. Whatever the last number is just your P of -5. If you don't believe, you can plug in -5 into here, all right? And you can plug in. It's going to be the same answer. Now, Aiden just now already showed the synthetic divisions. Now you can you tell me what's the possible rational roots? What is the possible rational roots?
One.
Who is
Negative.
on the top?
I think 1 is.
The factor of the constant term is on the top. 1, 2. Come on, tell me, next one. Factor of 12, go ahead.
4.
You can do 3, right?
Yeah, you can do 3. Yeah.
And then 4, and?
6. 12.
Yes. Divided by? The factor of this guy, right?
Okay, so 1.
Which is 1, okay? So that's PRR, okay? This is PRR. Possible rational roots are this. All right, yeah, that's it. And next one is called the PNI chart. I haven't teach your people PNI chart yet. So let me introduce you. PNI chart. Okay. So you have your original function as this. This is your PX. And when you see this one, let's see how many times the sign get changed. Here is positive, here is negative. So from positive to negative, the sign change 1 time. And here negative stay negative. And then negative here change to positive here. So 1 time, 2 times. You count number of times change for the sign for your PX. And then you put 2 here because 1 time, 2 times. You put 2 here. And then you put negative. You put negative x here. When you want to replace x by negative x, so all the odd terms, you switch signs, correct? If you have a negative x to the power 3, that is negative x cubed. But if you have a negative x squared same as x squared. So this term keeps the same. And this guy, -2 times negative x is going to be positive 2x. And the constant term keeps the same. Ted, do you understand?
Wait, could you explain what? Wait, have you only explained what P was, or did you say what N and I was?
I just explained what P is. P is
okay.
check this original function, how many times your coefficient change the sign. From here to here, one time. This one, there's no sign change. From here to here, second time, so you have P as 2. But if you want to check n value, you need to write down P negative x first, okay? You need to write down P negative x first. P negative x, you plug in negative x into this, you change x to negative x. Okay, you change x to negative x. And this guy is this. This guy is x squared, so this is negative 4x squared. Minus 2 times the negative x, that's plus 2x, and then plus 12. So this is P of negative x. And now you want to check number of sign change. Negative, negative, no change. Negative, positive, change. One time, okay? So you have n here as 1. Here as 2 because 1, 2, correct? And your total number is 3. So your imaginary will be 0. So watch out over here. P is the number of sign change for your original function, px. N is your number of sign change for the P of negative x. When you have this chart, you list the P and N from here and from here. Next, you find the imaginary roots. Yeah, last class, students asked me about how do you tell if this polynomial have imaginary roots or not. So you are going to use this thing called PNI chart. When you have 2 positive roots, 1 negative roots, total number, highest order is 3. So 2 plus 1 is 3. Then you have 0 imaginary roots. But there could be other combinations. Your P has 2. You can give all these 2 to the imaginary. Okay? So the PNI table is very interesting. P can give to I. N can also give to I. But when you give those roots to the imaginary roots, you have to give it in pairs, okay? You have to give it in pairs. So you can say 0, 1, 2. But you cannot say 2, 0, 1, because this guy only have 1. There's no even number you can give to the I at the same time. So there are only 2 different ways, either 2, 1, 0 or 0, 1, 2. So far, any question? No question? Same thing as what we did just now with Aiden together. They ask you, is there any other roots? Okay. So we want to see based on the polynomial continuity, okay? Polynomial is always continuous. Why? Because we can see here, okay? We can write down any kind of polynomials. Yeah, I'm just writing down some crazy polynomials. 9x to the power of 7, okay? Minus 55. I just gave some crazy numbers, okay? Randomly. And you always see that all the graph are continuous graph. There is no discontinuity. And then plus 8x to the power of 5, and then minus 36 times x to the power of 4, and then plus 8x cubed minus 4x squared, and then plus 5. Okay. Yeah, you see this is a crazy graph. Okay, it is always connected. All the points are connected to each other. There's no jump, there's no discontinuity. So all those polynomials and everything for polynomials is always continuous. If you see one point above the x, you see 1 point above, 1 point below the x-axis. So there must between that 2 points, you have one of the roots, as what we see over here. When x is 4, 1, 2, 3, 4. When x is 4, y equals to 4. When x is 4, y equals to 4. When x is 3, y equals to -3. Okay, so you have these two values. Yeah, these 2 points is on your polynomials, on your graph. You know they are connected, right? Continuous function, you have to connect this by a line. When you connect them, is there a way that you can connect these 2 points, but you don't pass this one? There is no such way. You cannot jump. Yeah, whatever you connect, you have to pass this. Okay, you have to pass this. So this guy, you have a roots between 3 and 4. That's why you write down here, you have roots between 3 and 4, because f4 is positive, f3 is negative, so you must have roots between 3 and 4. And -1, when x is -1, the polynomial value is 9. When x is -2, polynomial is -8. So you must have roots between -1 and -2 also. All right. Now, next question is even harder. Will the roots in part f and g be rational or irrational? So this comes to the same question with what we did earlier with Eden. In this question here, you have a real roots between 0 and 1, because this is the places where you switch the sign. And then you said there is a roots between x equals 0 and x equals to 1. So you look for your PRR table, your PR table here. Do you have a value between 0 and 1? Yes, 1/2 is a very good candidate. Okay. And when you solve this one, and you do notice that, yes, you see, 1/2 is your roots. Yeah, you confirmed your conclusion. 1/2 is one of the possible roots, and also because 1/2 is listed in this PRR table. So 1/2 is one of the roots. Okay, and you confirmed by solving this. So that's correct. but not always. If in this one, you don't have a selection of 1/2, then you say no, okay? If you don't have 1/2 here, then the answer is no. So the example is showing over here. What you see here is, you say you have a roots between 3 and 4. And you also have roots between -2 and -1. And let's check your PRR, okay? Your PRR is right here. Do you have a roots between 3 and 4? Yes, you have a roots at 3. You might have a PR roots at 3. You might have a PR roots at 4. But there is no number showing here, which is between 3 and 4, okay? You have a roots at 3, which is good, okay? You have roots at 3, which is good. And you have a roots at 4, which is good. But in this guy, in this list, you do not have a number which is between 3 and 4. And in this table, you do have a -1. You do have a -2. But in this table, you do not have a roots between -1 and -2. So the answer here is no, because both of them are irrational roots. That's the reason, because there are no possible rational roots. There are no possible rational roots in your PRR. In the PRR list, between 3 and 4, between -2 and -1. Between means between this, okay? Not on the edge. The edge doesn't count. You need to look for the number between. You need to look for the number between. And then they ask you, are there any imaginary roots? Is there any imaginary roots? So you can tell you have at least one positive roots. Yes, you know, you for sure you have to have one possible roots between 3 and 4. And then because you have at least one positive roots, so you have to choose this option. Because this option saying you have no possible roots, but you already can show that you have one possible positive roots. So this guy will be selected and this guy will be denied. So PNI chart tell you you have 2 positive roots, 1 negative roots, and 0 imaginary roots. Okay? And you might wonder, is this really true? I haven't drawn this one. How do I tell? Well, for the test, you are not allowed to use calculator, but for understanding, you can use calculator to verify. Okay, this is polynomials. And what you do here, you see the roots, okay? You see the roots. One of the roots is this. One of the roots is here. One of the roots is here, okay? Yeah, you have 3 roots. And you can solve that roots by yourself. What you do is, you already notice that here is your synthetic tables when x equals 2. This is divisible. So that means this is 1 times x squared minus 2x minus 6 equals 0. So how about we solve this equation to find out the other two roots? Okay. That's right, right? Yeah. So you have, this shows that 1 plus square root 7 is a positive. This is a positive radicals. And 1 minus square root 7 is a negative radicals. Okay, radicals is irrational, okay? Radical number is irrational number. So you have a positive roots, which is 2. You have another positive roots, which is 1 plus square root 7. And you have a negative roots, which is 1 minus square root 7. So which is this? Okay, which is this? Correct? Yeah, the question here showing is still not hard yet because it is just x to the power 3. So definitely not hard enough yet. And this is just up to x to the power 3, you know. For Clemens, I see they give some question like x to the power of 10 or even 12, you know, with a very long synthetic division tables. So far, any questions? No questions? All right, if no questions, you're welcome to do number 4. I already explained 3 examples. It's your time to do this question by yourself and text me your answers, okay? Text me your answer A and B and C. Go ahead, do ABC first. Yeah, Olivia already got all the question A, B correct. Is there any other student? Yeah, Ted also get A correct. That's right, Ted. Other students? Yeah, Olivia also get PRR correct. How about other students? I don't see other students. Only Olivia and Ted text me the correct answers. Other people didn't write down anything. Okay, so over here, we can do this guy, x to the power 0, x squared, x cubed, x to the power 4, okay? So the first question is very simple. This, plus them together. That's it. One roots, you look for which one give your last digit to be 0. So that's it. Okay, x equals 2. Possible rational roots, you are using that guy factor. 12 factor is who? 12 factor is 1, 2, 3, 4, 6, 12. 2 factor is 1, 2, okay? So these are your possible rational roots. This is your possible rational roots. And then when you do the PNI, Olivia, let's check the PNI. Based on this, what should I put for P?
I'm actually still kind of confused about the PNI.
So this is your original PX. P is the number of sign change, positive, negative. So this is counted as 1.
Oh, all right.
Okay, this is 1. This is negative, this is positive. So this is counted as 2. This is positive, positive, no change. So you don't count. Here is positive, negative. So count 3. 1, 2, 3.
So there's 3. Left two?
Yes. Mhm.
Okay.
And then when you do the n, you change this first, okay? You have here, right?
Yes.
And then n is number of change for the sign. This is 1, correct?
Numbers. Oh, okay.
Yeah, only from this positive stay the same, you don't count. This is positive, stay the same, you don't count. Positive, negative, you count as 1 time. Negative, negative, no change, you don't count. So the P is 3, N is 1, okay?
Okay.
That makes sense?
Yeah.
But when we do the PNI, we need to do the distributions, okay? This has 3. You can give even numbers to the I, okay? Right?
Yes.
1 is odd. Yeah, this is just 1. You cannot give this guy to I, okay? 3 will give 2 to I. So 3 has 1 left. So this is 1, 1, 2. So this equals to 0. That means you could have 1 positive roots, 1 negative roots, and 2 imaginary roots. Or you could have 3 positive roots, 1 negative roots, and no imaginary roots. Okay?
Okay.
Makes sense, right?
Yeah.
Real roots. So when you look for real roots, look for the places where they switch the sign. Okay? Yes.
Yes.
So here. Next. Did your school already teach the least upper bound and the greatest lower bound?
No.
They might teach you later. Okay. Yeah, I introduced this in advance. When you see LUB and GLB, this is very confusing. It's hard to remember and it's hard to do. What I do is I don't care the list. I don't care this guy. I don't care this guy. I only care about the upper bound and the lower bound, okay? Upper bound is going to the positive direction, okay? It's going to go to the positive direction. And you see the first place that you see those values have all the same signs. You see here? This is the first time that all these numbers are all positive, right? This is positive, this is negative, this is negative. No, this is not correct. There is positive, negative. No, this is not correct. This is not correct. And only this layer, everybody is positive, correct?
Yes.
Okay, that makes sense?
Yes.
So when you see everything positive, you call this guy upper bound, okay? This is the upper bound. All right, this is upper bound. And then you can see the lower bound. The lower bound is going to this direction, yeah, because this is going up, this is going down, okay? Yeah, going up means the number is going up, not the direction, okay? And then you go to the small numbers. This is called lower bound. And you want to see the first place where you see the sign switch, okay? You see? Positive, negative, positive, negative, positive. So your lower bound is -2. Okay. All right. Yeah. Because the pandemic and also the winter storm, many schools just skip this part. They don't teach you, but they could still test you, you know. That's why I want to teach students these hard topics. Now you want to find, you can look for those roots because you see here, you know for sure you have roots between here, right? Yes. You know,
Yes.
for sure you have roots between here. And you also know that you have roots here, right? Yes, you already know you have roots here. So you can do 2, -3, and 4, 6. Yeah,
Yes.
2, -3, -4, and 6. And you know you have roots from here to here, and you can, this is your PRR. This is your PRR. So what you can do is you can try those values to see who can make this part to be 0. Yeah, this is just a try. Okay, try different values to see. Try different values to see. And you keep trying until you find out that 3/2, when you do the synthetic divisions. So when you do the synthetic divisions over here, 2 is pulling down to here, and then 2 times this is 3. 3 minus 3 is 0. This times 0 is 0. This plus this is -4. And -4 times this is -6. And then 6 minus 6 go to 0, okay? So by here, you say, wow, that's good. That means that guy is my roots because this ending with a 0. So you have 2x squared minus 4 equals to 0. Does that make sense? Then you find out your roots is positive and the negative square root 2. So here is your roots. And when you are asked to draw this polynomial, if you were asked to draw these polynomials, here is how you draw it. You have +2, and you first have 3/2, and you have so you have roots at, this is 1, this is 2, here is 1, here is 2, okay? And you have the roots at 2 over here. And you have roots at 3/2, which is 1.5 over here. And the plus or minus square root 2. Square root 2 is about 1.414. Okay, so 1.414. You can choose the roots around this location. This location, and you have a -1 on the other side. So this 4 purple dots are your roots. Okay, so you can draw, because the leading coefficient is positive. Let's see, the leading coefficient is positive. Okay, so it has the power of 4. It's going to be something like this, and you have a y-intercept at -12. So you have a roots, you have a y-intercept at -12 over here. Now we can connect them by smooth lines, okay? So you're going down, and then you're going up, and you are pulling down by these roots, and then you are pulling up. All right. That's it. That's how you draw these polynomials. All right. I know this topic is pretty hard for many students. You have to keep trying. Make sure you do this homework. I attach all my notes, all the procedures. You have to practice to master. Yeah. Algebra 2 students, you can exit the class now. All right, all the students joined the class already.